characteristic is that the graph of the curve is bell-shaped. So when you think of the normal distribution, you need to think of a bell curve. Okay? It's a bell-shaped curve, just like that. It's symmetric with respect to the mean. So what that means is that your mean is going to be smack dab here in the middle. And on the left and the right, they're going to balance each other out. Okay? The mean, median, and mode are equal, and they're located at the center. So the mean, median, and mode are central tendency values. Will be right here in the middle. The curve is continuous, which means there are no breaks, and that the curve approaches but never touches the x-axis. It keeps going on forever and ever. Okay? The total area under the curve is equal to 1 or 100%. This is a pretty important characteristic right here. Okay? So the area under the entire curve is 100%. Have to know that. Now there's some more characteristics about the normal distribution, and that's what's known as the empirical rule. This is taken from your book on page 675. Okay, the empirical rule describes areas under the normal curve over intervals that are 1, 2, or 3 standard deviations from the mean. Now, the biggest thing what you need to do and what you need to get down is the following. Write down here these 3 things. Now, you don't have to write the whole thing out. Okay, you don't have to write everything out. All I would probably do is write the fact down that approximately 68% of data values fall between 1 standard deviation. Okay, you could actually get this done. Right here, you could get rid of that. And this one would be 2 standard deviations. And this one would be 3 standard deviations. Now, what that means, if you deal with something that's a normal distribution, and you've got your average here in the middle, right here. If you go 1 standard deviation to the right, 1 standard deviation to the left, 68 values will be in there. 68% of the values. So if you have 100 items, they're normally distributed, 68 of those 100 items will be right here in the middle. Now, if we were to extend that and go to 2 standard deviations from the mean, if you go 2 standard deviations from the mean, we're now dealing with 95% of the values. 3 standard deviations, approximately 99.7% of the data values. Now, this deals with something known as confidence intervals. If you go on to take a statistics class, you'll talk about confidence intervals. I don't think we'll get to them this year. Okay? But that's what these deal with as well. And so that's the empirical rule. Biggest thing you need to know are those values. 68 is 1 standard deviation, 95 is 2, 99.7 is 3. Make sure you file those away. So now let's look at this. It says the heights of 880 students at a high school are normally distributed with a mean of 67 inches and a standard deviation of 2.5 inches. Approximately how many students are more than 72 inches tall? So if I were to think about this, they said it's a normal distribution, so it's going to be something like this, the normal curve, right? And here in the middle is what value? 67. Now, if I go 1 standard deviation beyond, that would mean a value of 69.5 to what value? 4.5. Now, what did I do? I went 1 standard deviation to the right, 1 standard deviation to the left, because it said a standard deviation was 2.5. And so in this area here, what percent do I have? 68%, right? So then now I'm going to go an additional, because I still haven't hit the 72. So if I go an additional standard deviation, that puts me at 72, and an additional standard deviation puts me at 62. And I know between those 2 orange values what percent exists. 90, what? 5. And so they want to know how many students are more than that. So 95% is in the orange, right? So how much is outside the orange? 5%. So that means I've got 2.5% here and 2.5% here, right? So they want to know how many students are more than that. What are you going to do with the 2.5%? Take it times 880 total students. Because you want to know exactly how many students. So if I take 880 times 2.5%, what does that give me? I got 22. Did somebody else get 22? Okay, I got 22 students. Why? Because you used 0.025. Okay, so 22 students are more than 72 inches tall. Okay, let's look at the next one. What percent of students are between 59.5 and 69.5 inches tall? Okay, so let's think about that. I've got 69.5 here, right? That's 68. If I put this right here, this is 59.5. Correct? Okay. So let's see. There's 68. So here's 68. This is what? That's 13.5. So I have 60. Oops, let me get pen. I've got 68 plus 13.5 plus how much? 2.35. That was how much on. If you're wondering, this is where we're looking at. We're looking at this percent here, and this percent here. That's what it correlates to. Okay, that was the exact same. So if I add all three of those together, I get 68, 13.5, 2.35. What percent is that?
It's
83.85%. Now this one asked for percent, it just did ask for number of students. Okay. All right, questions? It's kind of important to know that one chart. Let's look at the next one. A machine used to fill water bottles dispenses slightly different amounts into each bottle. Suppose the volume of water in 120 bottles is normally distributed with a mean of 1.1 liters, standard deviation of 1.02. Approximately how many bottles of water are filled with less than 1.06? So let's go ahead, figure out what we got here. We got our normal distribution here. What's in the middle? 1.1. Okay, one standard deviation beyond puts me at what values? 1.12, 1.08, yep. And then the next one is going to be at 1.14 and 1.1 or 1.06. Okay, so approximately how many bottles of water are filled with less than? So what percent is going to be to the left of the 1.06 right here? Okay, let's think about that. Orange to orange is how many percent? 95%, right? So what percent is outside of that? 5% is outside, right? So how much is to the left here? 2.5%. The 2.35 is 3 standard deviations. So if you would go one more beyond, if you would go to 1.4 and 1.16. Okay, so 2.5%, so if I take 2.5% times 120, what do you get? Three total. So 3 bottles. So let's look at the next one. What percent of the bottles have between 1.08 and 1.14 liters? So here's 1.08, right? Okay, here's 1.14. So let's figure out percents. This right here is 68%. What percent is this? 13.5. So you have 68 plus 13.5, which is 81.5%. Okay? All right, questions on that? That's dealing with the normal distribution. All right, now we're going to talk about z-scores, and this is going to take us the majority of the time remaining. Okay, z-values are also known as z-scores and z-test statistics. It represents the number of standard deviations that a given data value is from the mean. The other thing you need to get down is this formula. This formula will be your best friend. Okay? All right? This is something that will follow you through. If you ever take another statistics course, you deal with the normal distribution, you will see this formula again.
What is that? X minus what?
X minus mu. Remember, that's average. So X minus the mean divided by the standard deviation. Okay, that's just that Greek letter mu, which symbolizes average. Yes, you might have to take a statistics course just depending on what you major in. So, actually, statistics for you should be fairly easy. For any of you that have had this background, you should generally be able to get through a business statistics course. So you need to file this formula away to memory. Z equals X minus the mean divided by the standard deviation. We will use it a ton. Okay, we're also going to use your graphic calculator as well. So X minus the mean divided by the standard deviation. And that might even be something you want to write down too if you wanted to do the Z. You could do X minus the mean divided by the standard deviation. All right, so let's go ahead and look at an example. Okay, oh, skipped it. Let's go back. There we go. Find each of the following. Z if X equals 24, mu equals 29, and sigma equals 4.2. Yep, that's all you do. Okay? No. So Z equals, what did I just say?
24 minus 29.
Yep, calculate that for me. I need it to 2 decimal places. 2 decimal places.
1.19.
There you go. That's it. Negative 1.19.
Yeah,
Yep.
sorry.
Negative 1.19. There you go. So now the next one. What's my formula going to look like? Negative 1.73 equals 48 over 2.3. So how would I solve this? Times it by 2.3 on both sides. Good? So if I times by 2.3, what do I get when I take 2.3 times negative 3.979 equals X minus 48? What I do now then is add 48 to both sides. So to 2 decimal places, what do I get X to equal? 40 what? So 44.02 equals X. There you go. So now what we're going to do is we're going to look at some more characteristics of the standard normal distribution. Okay, now this is different. There's one different word. What's the different word?
Normal.
Standard. Okay, we looked at normal distribution. This is the standard normal distribution, and what it does is that means that we have a normal distribution of C values with a mean of 0. Okay. Oh, I wanted to highlight that. With a mean of 0 and a standard deviation of 1. Now notice, it still fits a lot of the same characteristics. The total area under the curve is 100%. Almost all the area is between z equals -3 and z equals 3. The distribution is symmetric. The mean is 0 and the standard deviation is 1. Okay, the curve approaches but never touches the x-axis. So really the only difference versus all those things that you wrote down is this statement right here. The mean is 0 and the standard deviation is 1. So that's what you need to get down, a standard normal distribution. The mean is 0, the standard deviation is 1. And so what we're going to do is we're going to standardize problems so that they fit the standard normal distribution. Okay, so let's go ahead and look at an example of this. The average number of phone calls received by a worker each day during a 30-day month was 105 with a standard deviation of 12. Find the number of days with fewer than 110 phone calls. Assume that the number of calls is normally distributed. So the first thing you need to do, what is the mean? The average. So which in this problem is the average? 105. Good. So here's our mean. What is the standard deviation? Oh. Okay. Now, when I think about z values, this is going to be what my x value is, 110. So what I'm going to do now is create a z value. I'm going to find what 110 is. So I've got x minus what? 105 divided by 12. So what is your z value going to be here? Yep, which is what as a decimal? So 0.42. Okay. So now we want to find, this is what corresponds to 110. We want to find the number of days with fewer than 110 phone calls. So what is another name for fewer, or what is another symbol for fewer? Less than. So I want the probability that x is less than, and instead of putting 110, I'm going to use 0.42. And so in order to find this, I'm going to use a function on your calculator. All right, this is where you need to go. You're looking for the normal CDF. Now, this is how you find the normal CDF. You are now going to second vars. Okay, second vars. Vars is located right by your down arrow. Where do you see the normal CDF? Number 2. Now, it's going to ask you for a few things. Does anybody's bring up lower? Okay, so it's going to put parentheses. So this is what you're going to type in for those of you that don't have what I have on the screen. You're going to type in -E99. Now, where do you find the E? You find the E right above the 7 where it says EE. Okay. Then what you're going to do is you're going to hit 0.42. Okay, yes, you have to put a comma.
Okay, so if that's what we need to have, if it looks like yours,
What?
that's what we need to have if it looks like yours, or if it doesn't look like
This is what you need to have if it doesn't look like mine.
yours.
Okay? You're going to go up to 0.42. Okay? So, -E99.42. And if you go ahead and, then you're going to do comma 0, comma 1, and then end parentheses. Okay, what did you get when you typed that in? Okay, what'd you get? 0.6628. So what that means is that corresponds to a percentage. And so that means that your answer to that is 66.28%. So you remember on those other problems when we looked at the graph and we said this one was like a 54% or something like that? This is what you actually get here, and I don't have to graph it out.
Is it always E99 or 0 9?
Okay, the negative e to 99 means negative infinity. Why did I use negative infinity? Because it was less than 0.42. If you wanted greater than, you would go from 0.42 to positive infinity, which would be e to the 99.
So you do 0.42, comma, E99, comma, 0, 1.
Now, we're going to look at other ones because it's going to take a while. There is another way to find these, and that's by using a table. Oops, let's go back to this one. Okay, this will probably be where we stop for today. The average number of points that a basketball team scored during a single season was 63. What does that indicate? Zach, you with us? What? What's 63? Mean. With a standard deviation of 18. So sigma. If there were 15 games during the season, find the percentage of games in which the team scored more than 70 points. Assume that the number of points is normally distributed. Okay, what is x?
70.
X is 70. Yep. So let's find the z value. Z equals, what do you get? 70 minus over 18. What do you get? Point what? .39. So let's look in the problem. Find the percentage of games in which the team scored more than. So what's that going to be?
Second bars.
Okay, no, it's going to be x is what?
Greater than
0.39. Now, this is what you're looking for. Now, let's think if it's greater than, what's going to be my first number I'm going to put here? 0.39, comma E99, comma 0, comma 1. This implies your mean. It'll always be 0. This implies your SD. Okay. So, go to your bars, normal CDF. Lower is 0.39, upper is E99. And you get what? 0.3483. So what's your percentage going to be? 34.83%. Okay, so real quick, what would be the percentage of games in which you scored less than 70? Percentage less than 70 points would be 65.07. Because remember, the total percentage is 1. So if you've used 34.83, the opposite would be 65.07. Oh, 17. Sorry. I missed that. You're right. It is 17. Good call. 65.17. There you go. Yeah.
Doesn't matter if you put 0 or 1 at the end, like the negative either way.
It always has to go 0, comma 1.
0, 1.
Yep. All right, so we kind of got to start there. What I will do is I'm going to go ahead and give you your assignment now, and then I'll go ahead and probably finish this on a video for you the rest of the time. Here you go on pages 681 through 682. I need you to do 2 through 20 the evens, and then 23 through 26. 2 through 20 the evens, and then 23 through 26.